Now we'll go to the chapter 8, Introduction to the GIS. So what is GIS basically? GIS is a abbreviation of the Geographical Information System, which is defined as a computer system that capable to hold and use data to describe places on the Earth's surface. So in detail, it is an organized collections of computer hardware. It must have a hardware, a good computer, a fast good computer, a software which is GIS, and many more, geographic data, and a personnel designed to efficiently capture, store, update, manipulate, and analyze, as well as to display all forms of the geographically referenced informations. So Wilkinson stated that GIS is a system contain a spatial database representing aspects of the cultural and physical environment of the particular geographic regions together with procedures for analyzing combinations of attributes and generating graphical or statistical products. So this is a bit of history about the GIS. Okay, you can see here, you can see here as well. Any more? And for the Malaysia, we started in 1986, where the JUPEM started to digitalize the character database. Then NALIS comes in, MyGDI, and now we have the GDI. We have most of the system now is in GIS. Okay. Now we look into the definitions of the GIS data. So data in GIS basically describe both the locations and characteristics of spatial features such as roads, land parcels, and vegetation stands on the Earth's surface. And this kind of data can be either in a vector or raster data. Raster data is basically just like satellite image photos. It has the pixels, and vectors is basically a line or point or a polygon that tells you features, represents the features. And information in the GIS also, we have the informations which is totally different from the data, where it implies some degree of the selection, organizations, and preparations for particular purpose. And this kind of informations basically give some degrees of the interpretation of from the data. And geographical informations, it could be map or digital, which is the information about the places on the Earth's surface. Okay, what is geographic versus spatial? Geographic refers to the Earth's surface, spatial refers to any space, which is more general. So in geographic information, it is a knowledge about where something is, and also what of the things and in a given location, where it can be detailed or very coarse, and it could be static or change rapidly. So why we use GIS? Okay, so the idea of GIS is a system of hardware, software, data, people, organizations, and institutions arrangement for collecting, store, analyze, and disseminate the information about the areas of the Earth, right? So different mapping systems where we have in the world now, okay, could be electronic atlas, thematic mapping system, and street-based systems. So in order to analyze it, to import, to export, to combination of different data is important. That's why we use the GIS, and of course to have a map update from time to time. So GIS is specifically a real application which includes the hardware, data, right, and also software and people that need to solve a problem. And GIS is a type of software basically, and hardware is a computer. But the most important thing is what kind of information that being stored inside the system. And additional, a GIS includes tools to do things with the informations, where it can have it has a special functions which work on the geographic informations. And this GIS basically uses the analytical powers of the computer to complete the complex tasks. Okay, and the integration of many different types of data from different sources, and GIS able to maps a variety of different data to the same coordinate spaces, where it allows a combination of the data. So what data component in GIS? They have the data input, the storage and retrieval, analyzing and manipulation, as well output and display. So we look into one by one. What is data input? Data input basically, it allows user to capture, to collect and transform spatial and thematic data into digital form, where it's usually derived from a combination either hard copy maps, aerial photos, remote sensing data, and many more. While for the data storage and retrieval, it organizes the data, spatial and attribute in a form which it permits to be quickly retrieved by the system and permits rapid and accurate updates to be made to the database. Where for the GIS system, it have its own database management system to maintain the attribute data. While for the data manipulation and analysis, for this system, it allows the user to define and execute spatial and attribute procedures to generate the derived information. And this is commonly taught as a heart of GIS, where other systems would not have this kind of analysis to manipulate the data. Okay, and data output, the last one, it allows the user to generate graphic displays, which is maps or reports. And in the GIS, there are two types of data, which is the spatial data. So spatial data basically, it describes the absolute and relative location, coordinate, x, y, and z, latitude and longitude of the geographic features. While the attribute data, it describes the characteristics of the spatial features, could be quantitative or qualitative, and usually is kept in the table. Okay, so here a vector data, basically, if we have a different kind of data being overlaid, it shows you an information, and those data is basically is kept within a table in every particular layer. So what are the components of the GIS? We have 5, which is computer system, the software, the people, data, and also the infrastructure. Okay, so what is in the GIS? So basically, when we talk about the spatial data, how we explore it. So spatial data is representations on our environment in graphic and in numbers, where both of them will be kept in the two components of the data, which is the spatial data and also the attribute data. So these are the how the representations of the data on the real world and inside the GIS as a point, line, and areas. Please understand this, as I will ask you in the exercise later. Okay, and in the GIS operations, there are spatial data input, attribute data management, data display, data exploration, data analysis, and the GIS modeling. Maps are simply the model of the real world, where it represents the snapshots of the land at a specific map scale. So the map legend is basically a key to identify which features are represented on the map, and it is a traditional method to store and display the geographic information. So the location and extent of features is identified explicitly by the reference to a coordinate system, which this is where the feature is, while the attribute is a feature described or characterize the features. So this is what the feature is, and the relationship of the features to other features is implied by the location and the attributes. So this is basically how or why a feature was there, or the purpose of the feature is basically shows the purpose of the existence of the features. So the GIS basically is distinguished between the spatial and attribute aspects of the geographic features, and the identification of relationship between features, which is a common theme within a common team or across different teams is a primary function of a GIS, where we can tell you basically the informations. Okay, if those data being combined together, it might show you different interpretations of the existence of the features on the Earth's surface. So there are two types of the data, as we know, and the data input process is the operations of encoding both types of data into the GIS database format, which is this is the main source of data. Okay, where it is a expensive part of the GIS, but not enough attention given to the quality of data or the process which are ready for automation, where 60% to 80% of the cost incurred during the GIS implementation lies on data acquisition, compilation, and the database development. Even though wide variety of data sources exist, but usually it is in the different kind of format, such as hard copy maps, aerial photo, remote sensing images, point data samples, and existing digital data, where to combine all of these data requires a lot of time, money, as well as the resources. And there are 4 basic procedures to input the data, such as manual digitizing, automatic digitizing, entry of coordinated using the coordinate geometry, and conversion of existing digital data, where requires a lot of time, effort, and also human energy, workforce to do all of this inputting. That's why data acquisition is very expensive in the GIS. So, but basically, when we talk about the GIS, they have a lot of advantage, such as the automated mapping, to use the digital stored information to create the thematic or topographic map quickly, simple and flexible, to do some simple query of the data, spatial analysis, which is the quantitative analysis for one or more geographic themes, spatial modeling, which is the complex examination of the processes which allow predictions or simulations of the data. Okay, and why we need the GIS? Because as we know now, as the world is going for the IR 4.0, the complexity of data is more and more. Okay, therefore it is needed for the GIS to manage the data efficiently, and the environment competition, which is a fast changing environment, need for the GIS for fast decision making system analysis in terms of spatial attributes. Such example, COVID-19 system. Okay, the government are using the GIS to monitor the COVID-19, okay, and also to track the person under investigations, and also to update the movement of the people. So all of it, okay, is due to the fast changing environment. It's important for the GIS to be used so that the policymakers able to come up with the proper decision making. So what are the applications of the GIS? There's a lot. Basically, there are agriculture, such as farm management, precision farming, pest or disease tracking, crop monitoring, yield forecasting, soil analysis, watershed or basin, land use information, forest management, and many more. That's all. Thank you very much.